another video before, and I think it's a little too long, so I'm going to do another one real quick. So, homework, make sure, first of all, that you do your makeup work first, which I'll try to send you an email with your grade report so you'll know what you need to do. If you make up work for last 9 weeks, it will need to be sent to me by Wednesday. I might extend it to Thursday morning, depending on how long it's going to take me to get you the emails out. So what I want to do now is I want to do the back of the poster project. So let's look at the poster project. So what you need today, you might need a calculator, you might need your naming wheel, and you might need your periodic table to help you out. So the very first page, we've already done. We did that to complete the very first part. Now, I've already done these, but I'm going to go over them again with you. So the first one that we have here is just basically where we're going to actually count numbers of how many elements there are. So the first thing I want to talk about is I want to talk about the concept of subscripts and coefficients. So if we have what's called a subscript, okay, a subscript is where we have a number that is attached to something, okay? So when you're counting elements first, you have to go and remember, if it's a capital letter, then it's an element. If it is a capital letter and a lowercase letter, then you know that it is still an element, remember? So right now I have 3 elements here. I have hydrogen, I have oxygen, and I have chlorine. Right now I have a subscript of 2, let's do 4 and 6, okay? So hydrogen has 2 elements, or 2 hydrogens in this compound. Oxygen has 4, and chlorine has 6. So if I take my calculator, and I say 2 plus 4 plus 6, that's going to give me 12, and that's how many I have. So that's subscripts, okay? Subscripts are attached to an element. Coefficient, for example, the very first problem that we have here, which is 4HF, okay? Capital H, capital F, that means I have a hydrogen and a fluorine, and this 4 gets distributed. So if you want to put a 1 there, you can. So 4 times 1 is 4. 4 times 1 is 4. So 4 plus 4 is 8. And that's how I got my 8 there. The next one is where we have nitrogen and hydrogen 3. Well, nitrogen has 1, hydrogen has 3, which will make it 4. 3ZnSO4. So we have 3Zn. Remember, Zn, capital letter, small letter, means it's an element by itself, and S, and then I also have a capital O, which is telling me that's sodium and oxygen. So Zn is 3, sulfur is 3, and oxygen is 3, and that would give me a total of, oxygen has 4. So that would be 3 times 4. 4, 8, 12, which would equal 12. So 12, 13, 14, 15, 16, 17, 18, a total of 18. Okay? So basically all you're doing here is you can just get you a piece of paper, write down the elements, write down how many there are, and see if you can do that. Okay? So let's do one more just to make sure that I didn't do before. So if I had 5Na2CO3, I have Na, I have C, and I have O. Well, 5 times 2 is 10. Remember, you multiply those two. 5 times 1 is 5. 5 times 3 is 15. So that's going to equal 30 number of atoms that are there. Okay? The next problem that's asking you is what they're doing is they're asking you to use your periodic table and fill it out. And remember, we have 8 men. So on here, I would do APEMAN. So A stands for atomic number, equals protons, equals electrons, mass number, subtract atomic number, equals the number of neutrons, okay? And I would have that beside me so I can look at it. So the first problem that we have here is we have beryllium. So for beryllium, we're going to look on a periodic table. We're going to find it. Well, there's beryllium right there. Atomic numbers first, which is number 4, right? And then the AMU is 901. Write down the name of what it is there. And then we're going to do our model, okay? So if we're doing Bohr here, we're going to look and we're going to say, all right, so if I look, beryllium's right here, right? Second period, right? So that means I'm going to have 2 energy levels. Got it? First energy level, I'm going to have hydrogen and helium. There's my 2. The next one is lithium and beryllium, which is 2 on the second energy level. And then I'm going to do my math for my protons, neutrons, and electrons. Well, we know that the AMU, which is 4, equals the number of protons and equals the number of neutrons. So, electrons. So I'm having 4 here and I have 4 here. And to find neutrons, I have to take the atomic number. And what do I have to do with that? I have to take the mass number and subtract it by the atomic number. So my mass is 9.01. My atomic number is 4. So 9 minus 4 is 5. And that's how I got it there. Okay? So that's the first page. The second page, what we're doing here is we're just pretty much writing down the words that fit in there. So you'll just have to do that. So then the next one is where it's asking us to take our periodic table again. Okay? Find the element. So sodium. So sodium is right here. Right? So sodium is atomic number of 11. It has 23 is the atomic mass, and it tells you to round it up, right? 22.99, we got to round up 1. And then the number of protons is 11. The number of neutrons is 12, because 23 minus 11, right, is 12. And then the number of electrons are 11. The next one is actually showing you an anion. Remember, anions, positive 1, positive 2, positive 3, positive negative 4, negative 3, negative 2, negative 1, and then no charge. Remember, cation has a positive number, and it donates. And an anion has a negative number, and it receives. Okay? So, what we're going to do here is, as you can tell, since it's a positive 1, I have to take 1 away from the electron. Because remember, with cations and anions, in ions, we are talking about valence, or better yet, electrons, not necessarily valence, okay? Now, so then the next page that we're doing is the naming part. So what you're going to need to do is you need to use your wheel. So the first one was C2F4. So the first thing I'm going to do, is there more than 2 elements? No, there's only 2, right? Is there a metal? Well, let's see. They're back over here. They're non-metal, so that's a no. So then I'm going to my molecular. So my molecular says write the name of the first element. Only write the prefix if it's greater than 1. Well, that's greater than 1. Remember, our prefixes are here, which is mono-di. So that's dicarbon. And then for F is fluorine, right? We're going to take fluorine off. We're going to make fluoride. And then we're going to look at the number 4, tetrafluorine. Next one is dinitrogen oxide. Okay? So, and then you're just going to go through and do those on the wheel. This is a reverse thing. Carbon tetrabromide. So, carbon is here. It has a +4, right? And then bromine has a -1. Well, that's an ionic bond, isn't it? So we're crisscrossing, and that's where we get the 4 from. But we also know there's a 4 there because it has tetra there. Okay? And then you're going to do those. When you get done with those, then you're going to submit them online for me. And then we're going to start a new unit tomorrow. Okay, guys? Love you. Bye.